right. So we got the hypothesis testing. Remember the first thing that we talked about was in case you forgot, was the null hypothesis. And then the alternative hypothesis. Now your homework is due on Wednesday, maybe a bulk assignment. Doesn't mean I'm going to talk about every single question numerically early. You have to jump down and find the answers to the questions we talk about. Alright, so, can somebody tell me the null hypothesis? What does it have to do with? Yeah. Just a basic idea. What symbols are used in the null hypothesis? Let's look at the whole of it. Yeah, it has to be equal some number. And where's that number come from? What's that called that we're testing? It's kind of important. Something to see, is it an and? Yeah. The number that comes from the clone. What's the symbols they're using in our null hypothesis? Yes. The symbols from the backboards. What symbols can we put here? Well, we can do P. What else? That would be the mean, we'll do a population mean. That's right. Well, it's 2 out of 3. What else is the boards on 7.5? Use mean, standard deviation, sigma. Okay? So something one of those three equal. Then what about alternative hypothesis? What symbols do we use there? X bar? No, we still use P, the mean, and sigma. And what math symbols do we use out here? Yeah, we got greater than, less than, what's the other one? Not equal to. And once it says something specifically about it, most of the time it's not equal to. And once it says something very specific, it's not equal to. And then we have our number from the claim. Okay? So remember, our two outcomes are we reject the null or we fail to reject the null. Those are our two outcomes. And those are the words you actually have to use. We are never supporting a claim. We're setting the test to either reject it or fail to reject it. Supporting it is a little bit different. We'll talk about that later, but right now we're reject or fail to reject. And what are some sample estimators we're going to use? What's a good estimator for P? Like the words back there. What do we use to estimate P from our sample? The symbols back there. Austin. What goes with the population proportion? What symbol are we going to use? P hat. What are we going to do to estimate the mean? What symbol? Okay? It is. Remember, there's two ways to do that. Either a z-score or a t-score. And then finally, to estimate the sample variance, we use S and then chi-squared. Okay? Alright, so it's all starting to come together, we hope. So we're going to talk more about it and keep going. Alright. The test statistic is a value used to make a decision like a null. It's found by converting a sample statistic to a score with the assumption that the null is true. Okay? So we are assuming that the claim is true. That's how we're doing it. But sometimes it's known as a proof by contradiction in mathematics. You assume it's true until something turns out false. Okay? So by assuming it's true, you go about your work, you do all your steps. The minute you have a false statement, that means the assumption is false, so null is not true. Okay? So as soon as you do that, the assumption is not true. Because statements have to be true or false. They can't be in between. There's no, we might or might not get out of school on Monday, Tuesday, so we are, we aren't. There's no in between. So that's a statement. So we assume it's true. Go ahead now, why? Assume that the null is true. It's a big test. Here's Z. What button do you use for Z also besides that one? To find the Z score. Yeah, we use inverse norm. This is P hat. This is P. You know what Q is? You know what Q equals? Yeah, 1 minus P. And here is what? Sample size. Okay. I can't remember if you have to use a formula or if you use a calculator. I think we use a calculator. Okay? For the mean, we already have this. Z and T. You better draw all three of them now just in case we use these equations for our test statistics. I think there's another way to do it. I don't remember it offhand. So jot these down just in case. Everybody knows test statistics for mean. I should have been doing. I don't know anymore. That's all about pictures and stuff like that. And then it must be 1 for the variance, standard deviation, chi-squared. N minus 1, remember the degrees of freedom. S is a sample. That's our sample standard deviation. That's our population standard deviation. So you might put some numbers in there and figure out even algebra to come up with some sample statistics. Okay. All right. Oh, did the notes come up today? Okay. Fantastic. The critical region, or ejection region, is a set of values testing that cause us to eject the null. Basically, if we say, remember I did that picture from the last test. If you say, to make the null true, everything has to happen in between here. If your test statistic comes out here, guess what? It's not a true statement. It's false. That's what it means by the set of all values are tested that cause us to reject the null. This is the ejection region. Everything outside of what makes it a true statement. Okay? You say 99.9% of all scores are between these two numbers. If you get one score out of that, move on to test statistic and try to deliver that statement. So, we're going to look at critical regions and test it and see if to determine whether they're true or not. Okay? We're not going to sit there and ponder and think and remember also after that say we also have the trap door. If we really don't think it's possible, that's going to happen. Regardless of what it says, that rare rule, you say, well, I don't think so. You can still use that as a way of rejecting the null. Significance level. It's about alpha. How do you find alpha? Remember? Yeah, 1 minus the confidence level. Okay? So, is the probability of testing the fall in the critical region of the null. The same alpha introduced in 7.2. The common choices of 0.05, 0.01, and 0.10. Remember, if nothing is given, I believe we assume is 0.05. Okay? So that's alpha. And remember, if we have two tails, we split alpha up into two tails like this, alpha over 2. Okay? If we do a two-tailed test. We can also be doing a one-tailed test, so this alpha is over here by itself. Okay, so we have to realize that. So, that's the significance level. Is the probability, so that's going to be a decimal, that the test statistic in the critical region where the null hypothesis is actually true. Okay. Sounds like all words, but through practice we should be able to figure it out. Lots and lots of practice. Alright, here we go. Assume the normal distribution applies on the critical values of z. Let's see what we remember. First of all, what kind of curve do I draw for z? Does anybody remember what kind of curve I draw? We just had the test. Yeah, that's a normal distribution. And two tails. Means if I add both tails together, that's equal 0.10. So, how much do I have right here? And how much do I have right here? 0.05. Okay? So, when I want to find my z-score, how did I do it? On the calculator. Inverse norm. What? 1 minus alpha over 2, 0 and 1. Here you go, right? Time to shine. What do I get? What is it? 1.64. What's the other one going to be? Negative 1.64. If you want to see on the calculator and you're going to use this button, remember, this has the right z-score. To get the left z-score, you do inverse norm of alpha over 2, 0 and 1. Then you got a shot. Not the 1 minus, just alpha over 2. Inverse norm, alpha over 2, 0, 1. And you should get negative 1.64. That makes sense? Okay? Make sure you understand the difference how to find the left z-score and the right z-score. Okay? The 1 minus is for this. And you can also talk about positive and negative, can't you? You should be able to. Okay, so we got 1.64 and then negative 1.64. The other. So that's good? Alright. Alpha is 0.01, H1 is P greater than 0.05. Assume normal distribution applies on the critical values of z. So the probability is greater than 0.05. So, means you have all this region right here for it to be true. Is that right? Here's alpha point. Oh, this is a one-tail test. Okay. P, 0.05 means the probability that it's true is in this region. So you see how we'll do inverse norm? 1 minus just alpha in this case, because it's a one-tail test. Alright? The reason I'm showing this region is because it says P is greater than 0.05. So go ahead and find this critical value. Yeah. Yep. Divide by 2 means for 2 tails. If you don't have it, you just take it off. at 2.326. Okay. Hopefully you got that. Do you know what this symbol stands for, H sub 1? That's the alternative hypothesis. You know what this symbol stands for, is P. Yep, it's our proportion, population proportion. Notice when it says our number is greater than 0.05, that's our claim. We have a white-tailed test. Okay? Make a note of that. Whenever it's greater than a white-tailed test, that means we're showing the white tail in the graph. If I would say less than, I think we'd do a left-tailed test. So what do you think the claim would be, H sub 0, since we don't have it there? What do you think the claim would be? H sub 0, how would you like that? Just based on this information. What would be the null hypothesis? What symbol would you use? Yeah, P equals 0.05. So it's testing some claim saying the population proportion is greater than 5% when this happens. Okay? So it's a pretty high number. So we're saying this is our region right here. Alright. Alpha is 0.005. P not equal to 45 minutes. The population proportion is 45 minutes. This one is known as a two-tailed test. Well, it's not equal to. Like I got right. So that means your alpha must be split up into both areas. So it's not equal to, I think it's a two-tailed test. Yes, it is. So it's a two-tailed test. So here we use P equals 45 minutes as our null hypothesis. Okay? So what we do is Z-score right here. How did you find it? You actually got two of them to find. Good? We'll get for one. 2.47, what's the other one going to be? Yep, negative 2.47. Okay? So those are test statistics. Those are we're going to figure out how to test that against the hypothesis. Okay? The claim. Right now we're just trying to figure out what the words and letters mean as far as how to calculate it. Okay? Negative 2.07. 2.81. How did you try a zero in the calculation? 2.81. Okay. Alright. Find the value of the test statistic. Oh my gosh. What words? What words? Okay. Over here? Okay. The claim is that less than half the adults in the United States have carbon monoxide detectors. A KRC research surveyed 1,005 adults years old and 462 who have carbon monoxide detectors. Okay? So, what's the claim? Yeah. The claim is less than, P is less than 0.5. I agree with that with the little stats I know. Sounds good. What would be the null hypothesis? Yeah. That's what I think. And so we're assuming this is true, right? So the alternative hypothesis would be, yeah. Well, I would say if we're assuming that the claim is true, right. And last time I thought, I think one of the words last time we actually put something in there. But, alright, we'll figure it out. I think it would be less than 0.5, I don't know. Why does this one use this instead of inverse norm? Why are these numbers used instead of inverse norm? Right, we have alpha. So, since we don't have alpha, let's go to plan B. How do you find P hat? Remember, P hat equals x divided by n. How many is our sample? 1005. How many have the carbon monoxide? 462. What's our population proportion? What do we say in our alternative hypothesis? 0.5. So this is going to be 0.5, 0.5, and this is going to be, what is it? 460, no, 1005, right? Alright. Sure enough in there, see if you can punch all that out in the calculator. If you want to do a TI, you have this. One parentheses, 462 over 1005 minus 0.5 divided by square root, another parentheses, actually I just did one right there. I'll do that one. 10.5 times 0.5 divided by 1005 and close it off. We have to type it all at once. I think they start adding some words on those equations for you. I'll get seconded. What's the for z-score? Anybody else get negative z-score? What'd you get negative what? Negative 2.56. Did you get that? Asking you that? Okay. So we don't have alpha, we have the old school. It is less than 05. I know, that's why we're taking our time.
So what's the actual answer? I know you have to write the negative 2.56.
Yeah, that's our test statistic.
And you have to write the...
No, you don't write that. That was just for fun.
What did you just do?
Well, remember we use inverse norm to find the z-score?
Yeah.
Well, now we find the z-score without knowing alpha. So if you have to make a picture, your picture looks something like this. You'll be right over here, show you right over there. Okay. That's our test statistic. Yes? Just this one. Okay? Yep, and look at this left there. It's a left tail test, isn't it? So that's a left tail. And that's our test statistic. And we'll come up with another test statistic later called a p-value. Okay? But it's starting to slowly add up. But we're taking our time through this. Hopefully we get done by May. Alright. The claim is that more than 75% of belts wear seat belts in the front seat. A Harris poll of 1,012 adults over 170 who say that they always wear a seat belt in the front seat. Find the value of the test statistic. Well, the claim is that P is greater than 0.75, right? Make sense? The null hypothesis would be that P equals 0.75, right? The alternative hypothesis would be what? Well, it says more than. I think it's greater than 0.75. We've been rolling with this claim for a long time, so I think we'll keep going with what it says. Until we come up for sure are we trying to support it or not support it. Well, right now I think we'll just go with how it's read. So that'd be what type of test is good then? A right tail test? I hope that is right. A right tail test. So V equals P hat minus P over square root PQ over N. How do you find P hat? X divided by N, in this case is what? 870 divided by 1012 minus what's P? 0.75 divided by, your thing is cut off. Keep punching. There you go. Square root of parentheses 0.75 times 0.25 divided by 1012. Hey, at least we know where our numbers are coming from. That's a huge improvement. It's not that difficult to type in once you do it once. Did you get it? 8.06? That's pretty high. That's like a rapid Z-score. It is. If some kid got on a test, I'd say, what is wrong here? That's right. Nice job. That's 8 standard deviations above the mean. That's pretty high. That's also pretty rare, so I don't think that claim is going to happen. Do you? I don't think so. Yeah, that's pretty high. That ain't going to happen. So work on some more of your problems, especially test statistics. I'll start this tomorrow. Like I said, you don't have time every day to keep up with your homework. Goes for everybody. So, we haven't talked about p-values yet, so stay with those. We'll talk about those tomorrow. Yes, sir, I'm still recording.